Wow, that's quite refreshing. Oh, hope you guys having a wonderful time, eh? That's good. Okay, so guys, this is the part two of the video. So in the last video we discussed the following question, if you still remember the question, when we were sketching the velocity versus time graph. So now we want to discuss sketching displacement versus time graph. Okay, so now the formula that we're going to use is this one. We said once we are dealing with graphs, more physics and maths, once you are dealing with graphs, you must think of mathematics or physics, né? Okay, so let's say I have delta, so I'm going to use this one. Delta y is equals to vi delta t plus 1 over 2g delta t squared, yeah? So now our graph, it forms a parabola. It's going to be bx plus ax squared, because of when you are sketching the graph, it's on our y-axis we have delta y, and on our x-axis we have delta t. That's why it's like this. So but the most important thing, I get this thing, it forms a parabola, so it means g is constant, also a is constant. Basically the g, it represents the a, and right to a from the parabola, it reports about the shape. So a from the parabola, it reports about the what? It reports about the shape. So if a, it's positive, so if you choose, let's say we choose upwards as positive, when we choose upwards as positive, korore g is negative, because g is always down. If g is negative, a is negative. A is negative, a is negative. Again, then why to if a is negative, shape ya graph in the, if a is negative, it's a sad one. Okay, then let's say you choose downwards to be positive. If you choose downwards to be positive, your g is going to be positive, a positive. So your graph is going to be like, this is going to be a set face. Again, but since it's at set face, we only take this part, so we only take this positive part, so we only take this side. When graph, your a is positive and then your b is negative. Okay, so basically the value of g, you just check g. If g is positive, you know that g is related a yako parabole. Okay, sharp. Now we're going to have a situation. Here we have a situation. A ball is thrown up with an initial velocity of 3 meters per second. It reaches the maximum height and then also reaches this thing. So when you do a velocity versus time graph, there are certain things that you need to take into consideration. It's what we call the reference point. The reference point. It means the reference point out the zero position. Once we talk about the zero position, it means now the reference point, if they say take the ground as reference, if bar take the ground as a reference point, it means bar take the ground as a zero position. It means you observe your motion only from the ground. So this is your zero position. So your zero position, your graph is going to be like this. Everything is going to be in the positive side. Your graph is going to be like this. So you just draw something like this. So that's your graph. Your graph is your zero position. So the black one, it represents the graph. So here take the top of the cliff or the top of the building, top red as reference. Top as reference. Top becomes your 0 position. Okay? So since the top becomes your 0 position, 0 ya how aim. You're going to observe the motion and then the rest is going to be what? The rest is going to be negative. Okay. So before now we can sketch the graph B. Okay, so now before we go to sketching the graph, I want us to firstly find the maximum height. The time takes from here to here. Right over here, the initial velocity is, so we take direction is very important, guys. You must take direction. Direction is very positive. So let's take upwards as positive. So if we take upwards as positive, it means everything that goes down is what? Is negative. So now I can use which equation of motion? I know my V here is 0. So I want to calculate the displacement. I can use this one. Vf squared is equals to Vi squared plus 2G delta Y. Because of this one, I have time. Then I can substitute. 0 squared is equals to Vi 3 squared plus 2 minus 9,8 delta Y. And from here, you can get your calculator to calculate delta Y. Everything must make sense. So Gobalim 3 squared divided by 2 multiplied by 9,8. Then I get 0,46 meters. From here to here is 0,46 meters. Okay, so now we're going to use this thing quickly to sketch our graph. So now let's say we take the ground. Let's say we take the top as a reference point. So it means now the top here becomes our 0 position. So the top becomes our 0 position. So moto O, and then since we took upwards as positive, Grr GR na is going to be negative. Grr A is what? Grr A is negative. And if A is negative, Grr graph na yo follow hona this motion. Yo bagam ko motion ulinkate. Then why to okay. Then you just say 0, then your graph will be like this. Then you can just substitute in the points. This is your 0 position. It means here your maximum height, it was 0,46, and then here, then your so this is A, this is point A, this is B, and this is C. More it is back to your hand. Displacement is 0. Then you have minus 10. It's when you take the top as the reference point. Okay, then we go back to the graph. When we're taking the ground as a reference point, it means we are observing the motion from the ground. So here observe this thing from the ground. And then okay, another thing, guys, the time. You can also find the time T1 here, then another time to reach T2, and then this is going to be our T3. You can calculate those times. You know how to calculate. You must know how to calculate those times. Okay, now the second one is when you take the ground as a reference point. It means our ground become the 0 position. It means I'm observing the motion from the ground. Then go one of this thing is amaso. Okay, then I'm going to have something like this. So everything is positive. So robana motion amaso. So now robalengi, it means moke 10 meters. Then you over 10 meters plus the makes elites are mailing from the top of the cliff. So go about 10,46 meters. This is my position A, this is my B, then it means this one is my C, where it reaches the same position. You must know the time. So the time to take reach maximum height, we can call it T1, T2, then time to reach the ground is T3. So this is the displacement versus time graph. So this one is taking the ground as a reference point, and then this one taking the top as the as the reference point. Okay, so I will also do another video when we change the directions.